Hi grade 10s, here's a bonus video for you. It's not mandatory that you watch it, but I know some students had some questions about our last video about elimination, where you had to multiply both equations to make it work. So I've decided to make one last video, and please only feel like you need to watch this if you're confused by my last video. So I'm going to look at these two expressions, 1 plus 2y and 2x plus 3y. And we're just going to look at the left-hand side of the elimination part, so we're not going to worry about what it equals to, but we know that if we were to use elimination, we need to make either the x's the same or the y's the same. So what I've done is I've made the x's, the blue part, pieces of Lego, and I've made the y's, the white pieces of Lego. So at the top, I've got 1 blue and 2 white, so that means 1x plus 2 y's, and on the bottom I have 2 blues and 3 whites, so that means I have 2 x's plus 3 y's. Now, what I want to do is I want to use elimination, so I need to make sure I either have the same number of blues or I have the same number of whites, so I'm going to make the blues the same. And I can make the blues the same by doubling that top amount of Lego. So instead of having 1 blues and 2 whites, I'm going to make it 2 blues and 4 whites. And now we see that we have the same number of blues, which is the same as having the same number of x's. So I'm going to subtract 2 blue minus 2 blue. They cancel out, they disappear. 4 whites minus 3 whites just leave me 1 white. Let's look at what that looks like. I'm subtracting 2 blues minus 2 blues would give me no blues at the bottom. 4 whites minus 3 whites would leave me 1 white at the bottom. And remember, the white 1 white is like a y, so that means that when I try to eliminate, I'm left with 1 y and I'm left with no x's, so my elimination has worked. And let's look at to see what that looks like as an algebraic expression. It looks like this. Actually do this question another way. Instead of eliminating the blues like I did the first time, I can eliminate the whites. So what I'm going to do is I have 2 blues and 3 whites on the top, and then 1 blue and 2 whites on the bottom. I'm going to double the top amount of blocks that I have. So that would mean that instead of having 2 blues, I have 4 blues. Instead of having 3 whites, I have 6 whites. So I have doubled what I have on top. Now, that doesn't seem to work because on the bottom, I only have 2 whites, and on the top, I have 6 whites. So we're not quite there yet. But let's look at the algebra to see what we've done. All we've done is we've taken our top equation, 2x plus 3y, and we've multiplied it by 2, so that means I would have 4 x's plus 6 y's. Okay, now, what can I do to the bottom blocks to make the whites the same? I think what I could do is I could actually triple the bottom number of blocks. So I started off with 1 blue. If I triple it, I have 3 blues. I started off with 2 whites on the bottom. If I triple it, I have 6 whites. And the great thing now is that my whites in the top row and my whites on the second row are exactly the same. I have 6 whites on the top, I have 6 whites on the bottom, so I can eliminate those. So all I've done in algebraic form is I've multiplied the first equation by 2, I've multiplied the second equation by 3, and so I end up having the same number of y's. I end up with 6 y's on the top, and I end up with 6 y's on the bottom, just like I wanted. And when I have 6 y's on top and 6 y's on bottom, that's when I can eliminate. That's when I can cancel out the y's because my y's are the same. So let's see what that would look like with my blocks. I want to take my 6 y's at the top, I want to subtract my 6 y's at the bottom, but that means I also need to subtract the blues. So if I subtract the blues, I'd be left with 1 blue. And if I subtract the 6 whites minus the other 6 whites, I'm left with no whites. So I've actually eliminated the white blocks, but the only way I could do that was by doubling the top and tripling the bottom. So sometimes you need to multiply the equations, both equations, not just one of them. So let's try an example now. Okay, we're going to try an example where there's no more blocks. It's just us doing math on a piece of paper. So this example here actually has a lot in common with our last example. I've got -5 blues, and I've got 2 whites is equal to 32, and then I've got 2 blues and 3 whites equals 10. So what I need is I want to make my y's the same. I want to make the number of white blocks I have the same. So we're going to do the exact same thing we did in the last example. Okay, so I'm going to triple the number of blocks I have up here. If I triple the number of blocks, I'm tripling the number of blocks, this means I would have 6 y's or 6 whites. And this number here would be 96. -5 times 3, if I triple that, would be -15x. This is plus 6y. So all I've done is I've tripled the top equation. Now, I can now see that if I were just to double this bottom equation, instead of having 3 whites or 3 y's, I would have 6 whites or 6 y's, so then they would be the same. So I'm going to double this equation. So that would mean 2x times 2 gives me 4x, 6y times 2 gives me 6y is equal to 20. Okay, so now I've got 2 new equations that I'm going to work with together. And those equations are awesome because I have the same number of y's, so I can eliminate them by subtracting. So if I'm subtracting, I need to subtract everything. 6y minus 6y gives me nothing. 96 minus 20 gives me 76. -15 subtract 4 gives me -19x. So you want to take your calculator out and figure out what 76 divided by -19 is right now. So we know that our x is -4 when we use our calculator. Now all we need to do is we need to take one of our original equations, the ones we started off with at the beginning. So for example, I know it's a big jumble of mess here, but I know that this was one of the first equations. So I have 2x plus 3y is equal to 10. And what I want to do is I want to put my x is equal to -4 in that equation. So I'm going to cross off this x, put a -4 here. 2 times -4 gives me -8, plus 3y is equal to 10. I'm going to add the 8 gives me 18. 3y, oh, y is equal to 18 divided by 3, y is equal to 6. So the solution, always put it in brackets with a comma in the middle. My x is -4 and my y is 6. And the only way we were able to do that is we started with this equation where I had a 2 and I had a 3, and I want to make those two numbers the same. Now, I could have done, instead of changing the y's, I could have changed the x's. I could have multiplied -5 times 2. -5 times 2 would give me -10. And then I could have done 2 times 5. That would have given me 10, and then they would have also been the same. But then I would be eliminating the x's and not the y's, but I would get the same answer. Okay, so let's try one more example together. We have 6x, we have -3y in the top equation. In the bottom equation, we have 4x, and then we have 5y. None of those coefficients are the same. The 6 and the 4 are different, the -3 and the 5 are different, and also there's nothing I can multiply 4 by to get 6. There's nothing I can multiply -3 by to get 5, so that suggests I'm going to have to multiply both of the equations. Okay, so in this equation, I've got 6x, I've got 4x. Let's this time make our x's the same. So I want to do something to the 6 and the 4 to make them the same. Now, I could go 6 times 4, and that gives me 24. And I could go 4 times 6, that gives me also 24. So I could multiply the first equation all by 4 and the second equation all by 6. That would work perfectly. If I didn't want my numbers to be so big though, I could multiply 6 times 2 and that gives me 12. And that would mean I would have to multiply my 4 by 3 to get 12. You could do this equation either way. If you like just using the opposite number, like for example, if this is 6, always multiplying by the number down here by 4. And if this is 4, always multiplying by the number up there. That's totally fine. But some people don't like to work with such big numbers, so they would prefer to do 6 times 2 and 4 times 3, and you get 12. So I'm going to do this way. If you are keen to do this way, try it this way and see if you get the same answer, because you definitely should. So I'm going to take my top equation and multiply everything by 2. 6 times 2 gives me 12x. Minus 3 times 2 gives me minus 6y. 2 times minus 3 gives me minus 6. Okay, and then the bottom equation, I'm going to multiply by 4 by 3 to get 12. So I need to multiply everything by 3. So I get 12x plus 15y is equal to 3 times negative 9 gives me negative 27. So I'm going to use this equation and this equation together. And I've done a great job because these two are the same. So 12x minus 12x is 0x. I don't need to write it down. I'm subtracting negative 6, subtract 15. If I subtract these two, I also need to subtract these two. Negative 6 subtract 15 gives me negative 21. And then negative 6 subtract negative 27. Sometimes we make a silly mistake, but it's negative 6 subtract negative 27 actually gives me, oops, I should put y, gives me plus 21. So that means that y is equal to 21 divided by minus 21. Y is equal to minus 1. Okay, I want you to assure you, guarantee you, that if you would have multiplied this one by 4 and this one by 6 and done the elimination, you would have gotten the exact same answer. If you don't trust me, try it yourself and you'll see. So now we have the y is equal to minus 1. We need to find the x. So we need to start with one of the original equations, one of the equations that are in red. So let's use 6x minus 3y is equal to minus 3. Oops. 2 minuses there, just 1 minus. And we know the y is equal to minus 1, so I'm going to cross off this and put a minus 1 here. So negative 3 times negative 1 gives me plus 3. I need to take this plus 3, move it over. Now, please don't think that these give you 0. If I have negative 3 minus 3, it gives me negative 6. Divide by 6, divide by 6. X is equal to negative 1. So that means my answer is negative 1, negative 1. That is my solution to the system of equations. I would love for you to go to Desmos, enter those two equations, and prove to yourself that that is actually where those two lines intersect. I hope that was helpful. That was just a bonus in case you were confused by my last video.